Hello everyone. In this video I am going to go over the homework on linear regression. So we have three tabs here in this spreadsheet. One is real estate, two is penguins, and three is diamonds. And you can see I have a lot more than two columns in each data set, but we're just going to do simple linear regression in this video, so we'll only use two columns at a time. Now this first data set here, as you can see from the addresses, this is Selinsgrove, Pennsylvania. And these are the houses that sold in the past year in the Selinsgrove region, those for which data was available anyway, according to Zillow.com. And I scraped this data myself on April 21st, 2026. So it's going back to April of 25. We're going to select the columns for square footage, and price, and we're going to insert a scatter plot rather. Okay, so I'm going to click on the D above square foot, and then I'm going to hold down Control, and I'm going to click on the G above price. So that selects the two columns. Then I'm going to go to Insert, and the one that looks like just a bunch of dots. Do not connect your dots because they are just going to look like nothing good. So just scatter the dots with no connections. Okay, so there we go. So this is one dot per house. We can see on the x-axis the square footage of the house, and then on the y-axis is the price of the house. So you guys can see there's kind of a generally like upwards trend. The houses that are further to the right are also a little bit higher up in price. And especially on this side of the graph, as it gets to smaller houses over here on the left, they are in a lower price bracket. I would not say this looks exactly totally linear. I could see putting like a curve here maybe instead of a line, but we're only doing linear regression, so we're just going to use lines. All right, so number 2 is add horizontal and vertical axis labels showing the name of the variable that is on each axis. Yeah, so Excel is not great about doing this for us automatically. It could really stand to be improved. One of my students should go work for Microsoft and make it do this automatically because we only automatically get whatever was above the second column, and it just puts it as the title, which is not very helpful. So I'm going to add axis labels. If you're in Windows, you have this little green plus, and you can do axis titles here, and then you can just double click on them to edit them. Another way to do it is if you go to the, let's see, is it chart design? Yeah, chart design tab, then there's add chart element, and you can put axis titles on there, both of them. You can do one by one. Otherwise, if you're on like Mac or if you're using Web Excel or something like that, you kind of have to poke around in the menus until you find where to add the axis titles at. Then once they're on there, just be aware that Excel by default puts the left column on X or horizontal, and it puts the right column on Y or vertical. So the leftmost column was square foot. So this is going to be square feet or square footage, whatever you want to call it. In other words, the area of the house. And then on the Y here, or the vertical, this is price. Okay, and now that I've done this, the title at the top is kind of redundant, so I'm just going to delete that one. Or you can leave it, it's up to you. As long as you label the axes, that's the most important. All right, so now people could tell what this is actually a chart of. Number 3, we're going to add a trend line to this scatter plot. Make sure to check the show equation and show r-squared options. I think there's actually a couple of ways to do this. You can click on the chart and use the green plus again, and then I believe you can just check trend line. Or you can right click on the points and do add trend line. Or I think you can also do chart design, add chart element, trend line. So there's different ways to do this. And if you're on a different version of Excel, again, you just have to poke around and try to find it. Once you've got your trend line on there, that is actually not quite enough. You want to then format your trend line. Let me see if I can right click on it and yeah, format trend line. So you need to get the little menu up for changing things about the trend line somehow. And make sure it's selected linear. These other options are just like other ones that you can do, but we're only doing linear today. And then you're going to do, you're going to check these two boxes, display equation on chart and display r-squared value on chart. Okay, and then move those to where you can actually read them. All right. So what does the r-squared value tell you about the strength of the linear relationship between square footage and sale price? Highlight or bold one of these. So for this homework, I chose to give you guys like the little breakdown scale interpretation here for the r-squared values. So r squared can be between 0 and 1. And this is kind of a general guide to interpreting what it means. It is pretty field dependent though, so even if it's weak, sometimes that can still be really useful. And you see in this case, it actually is in the weak category. It's 0.26, so it's in this category right here. So I'm going to highlight that. Maybe I'll, oh, no, that does the whole thing. Maybe make it green or something and then bold it. However you want to select that is fine. Okay. But yeah, this is still like useful information that tells us, yeah, it's got a positive upward trend, as we can see. As the square footage goes up, the price generally goes up. But there's a lot of other stuff going on here, which is probably related to these other data points, like the beds, the baths. It's also got to do with like the age of the house, the location, all kinds of information goes into it, really. But you can see square footage it's one of the things that's influencing it. Okay, so using the equation, predict how much a house with 2,000 square feet would sell for. Okay, so now we're actually going to use this equation. So I'm going to move this down to where the area is to put the answer so I can actually read it. Okay, so we're going to use this equation right here. Let me make it nice and big. Y equals 79.623x plus 138,199. So what this is y is price and x is square footage. So if I have a house with square footage of 2,000, I can just plug in 2,000 right here for x, multiply that by 79.623, add it to this number here, and then that is giving me my y value, which is price. So basically it's telling me if I go to 2,000 here on the x-axis and I go right to this line and I want to find out what's the exact point right where this line is right here, that's what the y value is telling me. It looks like it's going to be about 300,000 if I estimate, but I'm going to calculate it exactly using the formula. Okay, so I'm going to do equals 79.623 times asterisk for times. Now I'm going to put in the value for x of 2,000 and then plus 138,199. Okay, and there we go. It was about 300,000 like I thought. Okay, you can put that into price format if you want, or just leave it like that is fine too. All right, so that is it for this question. Let's go ahead and look at some penguins. Okay, so this is real penguin measurements that were collected on Dream Island in Antarctica from chenstrap penguins. It's a particular species of penguin. During 2007 to 2009 by Dr. Kristen Gorman and the Palmer Station Long-Term Ecological Research Program. This is kind of like a learning data set that is included in a programming language or in software called R. We're not learning R, but it's just a nice data set, so I pulled it out and put it into Excel here for you guys. And then I isolated it to just the chenstrap penguins, which happen to all be from this island. So if you guys ever want to go live on Dream Island with the chenstrap penguins, I think it will be very cold there. Okay, so let's select the columns for flipper length and body mass, and then let's put a scatter plot. So I'm just holding down Control to get both of them, or you could click and drag across the top like that. And now I'm going to insert the one that looks like just a bunch of dots. And there we go. This is looking more linear to me than the last one, I think. It's more tightly clustered around kind of a line shape. It's generally going upwards. I think we have flipper length on X and body mass on Y. So let's go ahead and add those axis titles. If only someone made Excel do it automatically. So this is flipper length. And then the units here are millimeters. And then this is body mass. And the units are grams. Okay. And then I'll just delete the title now since I don't need it anymore. Okay. So I'm seeing generally that the longer the flippers are, the greater the body mass is. Or you could say it the other way around too. The greater body mass penguins have longer flippers. That kind of makes sense. They're probably larger overall in all ways. They most likely have larger bills too, I would guess. All right, so now number 3, add a trend line. I'm going to try doing it with my green plus this time and see how it goes. Trend line, yep, I just checked it and then it kind of popped. Oh no, I didn't quite. Yeah, this is just format chart area. Let's see, maybe if I click linear? No, somehow I have to get into the options myself by clicking right on it, and then These are color options, shadow. Here's my actual trend line options. Okay. And now I'm going to check display equation and display r² value, and I'll just move them to where I can read them out. Okay, so we got a stronger r² value this time. It's up in the moderate linear relationship area. This makes sense to me because generally body physical measurements of either like objects that were all manufactured at the same factory or species where everybody's coming from similar DNA, those are generally going to have like a pretty good linear relationship, like foot size and height and things like that. Okay, so 0.4116 is putting me into moderate linear relationship, so I'm going to select that one. All right, and let's see, what else do we need to do? Last thing is using the equation, predict the body mass of a chinstrap penguin living on Dream Island with a flipper length of 185 millimeters. Here I just put in these extra words about, like, it's not all penguins, it's chinstraps on Dream Island. And even in particular, it's like between these years, right? Because I don't know, maybe the other chinstraps living elsewhere, they might have a different relationship. They might be a little different. Okay. So just being specific to the data set that I have, this prediction should only apply to the actual data set that I was using. Okay, so now I'm going to use the equation. Here it is. I want to know if the flipper length is 185, so that's going to be my x value, because flipper length is on x. So I'm going to put in 185 to this equation. Oops. And I'm going to see what y comes out to be. So I'm doing equals 34.573 times 185 minus 3037.2. You could also do this part with a calculator, but I mean, Excel is a calculator, so I don't know why. You can just use Excel. But you can do it with a calculator if you want to, I guess. Okay, so 3,358.8 grams is how much this penguin would weigh. And if I look on the actual chart or graph here, I should be able to kind of confirm that that answer makes sense by going to 185 on the x-axis and then go up here and see where's my y value at right on this line here. And if I go over, where's this y value? Yeah, it's like a third of the way from 3,000 to 4,000, so 3,300. Yeah, makes sense. Okay, so I think this answer, I didn't make any mistakes. All right, now number 3, diamonds. Okay, so this data set is kind of crazy. I'm apologize in advance if any of your Excels crashed because this has 53,941 rows in this table. My computer's fine. I hope yours are fine. Maybe if you're on iPad or something, you might have trouble with this sheet. Sorry about that. Anyway, so this is a data set on more than 50,000 round cut diamonds, and it was scraped from the internet, in particular from this website, in February 2007 by legendary data scientist Hadley Wickham. So just for if you don't know who Hadley Wickham is, he famously wrote this R for Data Science book, and it is all about how to use his tidyverse collection of packages for R, which is a programming language for data science. So he created the tidyverse and a lot of these packages that work together really nicely for data science. And then he wrote this great textbook, which is actually open source. And here is his website where you can read the textbook and you can learn how to use R. And it's really great. I totally recommend it if any of you want to study data science. Actually, the first section here is examples using the penguins. So these are our chinstrap penguins right here. This is the data set that I took. Right, so anyway, this is Hadley's diamond data set. We are going to select the columns for carat and price and insert a scatter plot. Okay, so carat is A, price is G, and then we're going to insert scatter plot. And it takes a second because there's so many points. There's 50,000 and some points. And here it is. Whoa. This might be an occasion on which you might, if you're curious, want to change the options to make these markers a little smaller. So on my options over here, format data series, I can change to marker automatic. This is, I think, yeah, I want to like make these a little, oh, here it is, built in. Yeah, this is where I can make them smaller. Weep, weep, weep. It's actually interesting if you if you make them small enough to really kind of see what's going on here, there's some interesting stuff going on in this data set. In particular, like what is with these lines here? Like why is this line here? So this is because there's some kind of psychological barrier at 2 carats where if you're the person cutting the diamond, cutting it makes it shinier, like sparklier. But if you have a diamond that was above 2 carats, you kind of don't want to go below 2 carats, right? Because there's some psychology about wanting a diamond that's over 2 carats. And then you can kind of see the same thing is happening at 1 carat and also at 1.5 carats. And this is probably like 1 2/3 carats. And this one is what, I don't know, like 0.8 carats, 0.9 carats, something. Yeah, so this is about psychology, human psychology of numbers. Anyway, it's fun to look at. Okay, so you guys can see like there's pretty clear general upward trend. I don't know if I would call this trend linear, but it's upwards anyway. The bigger the diamond, the higher the price generally. Okay, so we're going to add the labels on the axes here. By the way, if you think this is like kind of cool, I invite you to major or minor in data science. And yeah, great careers out there. Okay, so this is carats, which was the leftmost column we selected. Oop, my computer's even being a little bit slow now because there's so many points. And then this one should be price. Okay, so now back to our questions. Try to move this. All right, what does the R-squared value tell you about the relationship between price and between carat and price? Oh, I forgot to add my trend line. Whoop. Okay, let me do that. Add trend line, linear, display. Okay, here we go. All right, so actually now you see we have a really strong R-squared value here. We are in the very strong linear relationship category. Okay, cool. Just kind of like I would have thought, the most important thing about diamond is the size for the price. There's other stuff too, like clarity, color, you know, that stuff. Depth table, that's about like the particular cut. Okay, anyway, using the equation, predict the price of a 3-carat round cut diamond listed on diamondsc.info in Feb 2007. So just making the point again that this prediction only applies to this dataset. We should be careful about applying it to other situations. The prices have probably changed since then, and this was only ever this website and this round cut. Okay, so now I'm going to use this equation right here, and I'm going to plug in 3 for the x value. So let me do that. Equals 7756.4 times 3 minus 2256.4. Okay. So we're looking at a price of 21,000. Oof. You know, I'm not actually sure what unit these prices are in, if it's like American dollars or South African dollars or something, but that seems like a high price. But if we look at the trend line here, if I go to 3 carats and I come up to where the trend line's at, yeah, I see that's pretty much like where it's predicting it should be at. And it's not showing my points. They went away. The top half of the points are missing. Excel, get it together, buddy. Can't have you falling down on the job here, Excel. Where'd my top half go? It was here before. Okay, well, this is why we actually have, you know, things like R for programming with like much larger data sets. Excel is not that great at handling huge data sets. So I invite you guys to take more data science and statistics classes and learn about how you can work with really large data sets like this one. It's pretty cool. All right, that's it for this video. Stop by my office hours or send me an email if you have any questions.